consider one problem for this drawing of shear force and bending moment diagram. Here I am considering one cantilever beam with point loads, 4 point loads, that is 500, 400, 300 and 200 at B, C, D, E, and A is the fixed support and E is the free end. So, and distance between these loads are 2 meters, 2 meters, 2 meters and 3 meters. So calculate shear force values. The shear force values are, already we know what is the shear force sign, either positive or negative. While considering the section, either right or the left of the section, if choosing the section right of this right and the upward forces are positive or upward forces are negative and downward forces are positive. If the section chosen left of the section, left portion, the downward forces are negative and upward forces are positive. Here to consider shear force values. So at point E, the shear force value is, choose section just left of the section. So this is the left of the section. These portion are the left of the section and these are the right of the section. So at the right of the section, the downward forces are positive and upward forces are negative. So 200 is positive. So positive 200 kilonewton. This is the shear force value at E. In the same way at D, shear force value at D. What is the, consider section just left of the this point load, left of the this point load. So what are the forces? Algebraic sum of forces at the right of the section is 200 plus 300. So downward forces are positive to the right of the section. So plus 200 plus plus 200 and plus 300, totally 500 kilonewtons. In the same way, shear force value at C, choose the section just left of this point load. So these loads are right of the section. So right of the section downward forces are positive. So overall 400 plus 300 plus 200. So plus 200 plus 300 plus 400. Sum of these equal to plus 900 kilonewtons. Here the symbol is positive or negative is the very important while drawing of shear force and bending moment diagram. The same way, next at shear force at B. So here consider the section just left of the point load and the right of this section loads is 500 plus 400 plus 300 plus 200. So plus 200 plus 300 plus 400 plus 500. So total loads are 200 plus 300, 500, 500 plus 400, 900, 900 plus 500, 1400 plus 1400 kilonewton. This is the shear force value at B. In the same way, shear force value at A. So at A, the shear force values are nothing but these are the total values comes under shear force value at A. So here the shear force value at A is nothing but 1400 kilonewtons. These are the shear force values. In the same way, calculate bending moment values. The bending moment values is nothing but bending moment is force into perpendicular distance. So this is the important perpendicular distance, not any different distances. Consider perpendicular distance between the force and considered point. So bending moment at E here the bending moment at E is 0 because of already we know at we discussed here the bending moment at free end of the cantilever beam is 0. So bending moment is 0. In the same way, while consider this point load and perpendicular distance, the point load is at the end of the beam and distance at this end of the beam is 0. So bending moment is also 0. So consider 200 is the point load and distance here 0. So this is also equal to 0. Next, bending moment at T. At D, bending moment due to this 2 point loads are, this is the force into perpendicular distance. So take cantilever, clockwise is positive and anti-clockwise is negative. This is the clockwise. So clockwise, due to this clockwise load, the bending moment will be positive and force into perpendicular distance. What is the perpendicular distance? Force into perpendicular distance is 3 meters. Plus here 300 into distance is 0 because of we are considered that at same point. So distance is 0, that is equal to 200 into 300. This is the positive 600 kilonewton meter. This is the bending moment at D. Next, bending moment at C. At bending moment at C, consider the forces are at right of the section. So this is the considered point or section. The forces are right of the section is 200 plus 300. So force into perpendicular distance. Next, force into perpendicular distance. Here the forces are nothing but plus 200 into what is the distance? 3 plus 2. Consider up to here from E. What is the distance? 3 plus 2 equal to 5. Plus this is the, what is that moment? Clockwise moment. This is the clockwise moment. In the same way, next 300 into what is that perpendicular distance? This is the force and this is the perpendicular distance. Perpendicular distance is force into perpendicular distance. Perpendicular distance is nothing but 300 into 2. 300 into 2. Next 400 into what is the perpendicular distance from here to here is 0. So 0. Then equal to 200 into 5. 1000 plus 6. 1600 kilonewton meter. This is the bending moment at C. Next, bending moment at B. So same way, plus 200 into the perpendicular distance is 3 plus perpendicular distance is 3 plus 2 plus 2, totally 7. 200 plus 200 into 7 plus next 300 into perpendicular distance 2 plus 2, 4. So 300 into 4. This is the perpendicular distance between C and B. Next, perpendicular distance between D and B. Next, 400 kilonewtons. 400 into the distance is perpendicular distance is 2 meters. Next, plus 500 into what is the perpendicular distance between these points? We are considering at B and perpendicular distance at B is 0. So 500 into 0. Totally, what is that? 200 is 1400. 1400 plus 1200 plus 1400 plus 200, 2600. 2600 plus 800, that is equal to 3400 kilonewton meter. Bending moment diagram will write in terms of kilonewton meter. The shear force diagram units is shear force units is kilonewtons and bending moment units is kilonewton meter because of force in kilonewton and distance is meter. Due to this, the units are kilonewton meter. In the same way, at A, bending moment at A, At A, what are the forces considered? Total forces we are consider. We should consider total forces at bending moment A. So here bending moment A, the shear forces are bending moments are plus 200 into perpendicular distance is nothing but to overall distance from E to A is 3 plus 2 plus 2 plus 2, 6 plus 3, 9 meters. 200 into 9 plus 300 into, what is the perpendicular distance? 2 plus 2 plus 2, 6 plus 400 into 2 plus 2, 4 plus 500 into 2, 500 into 2 equal to how much? 1800 plus 1800, 3600 plus 4 for the 16, 4 for the 1800 plus 1800 plus 4 for the 1600 plus 1000, 2600, 2600 plus 3600, 3400, 3400 plus 4400 plus 4000, 5200, 5200 and kilonewton meter. This is the bending moment at A. So based upon these values, we draw shear force and bending moment diagram. So that shear force bending moment diagram will show what is the variation of shear force and bending moment diagram along the length of the beam. So let us see what is the variation of shear force and bending moment along the length of the beam. So first of all, you should draw baseline. This is the baseline. On this baseline, the shear force and bending moment values are 0. If suppose you draw this baseline for shear force diagram, the shear force values on this baseline is 0. For suppose you draw this baseline for bending moment diagram, the bending moment values on this baseline is 0. So draw this shear force value. We know already here the positive values are drawn above the baseline and negative values drawn below the baseline. Here the values of shear force diagram, all values are positive. So you should draw all the points above the baselines. So consider first shear force at E. Shear force at E 200 kilonewtons. 200 kilonewtons. Here 200, and then shear force at D is 500 kilonewtons. So 500 kilonewtons above this 200. Next, shear force at C is 900 above this, and shear force at B here, and shear force at A same. So already you know the shear force diagram between 2 point loads is constant. Between 2 point loads is constant, and the either rise or fall occurs at application of loads. So between these 2 point loads is constant shear force. Shear force will be constant straight line, and due to the increasing value, the shear force diagram will be rises. What is that? 500 kilonewtons here. Next, between these 2 point loads, the shear force will be constant, then it will be rises the same way. This is the shear force diagram. Total positive shear force diagram. Next, bending moment diagram. So consider baseline. So this is the baseline. The shear force values are positive, all are positive. So at bending moment at E, bending moment at E, the bending moment at E is 0. bending moment at E is 0. At bending moment at D is 600 kilonewtons. So at D 600. In the same way at C 1600. At C 1600. In the same way at B 3400. 3400. At A 5200. So 5200. The shear force diagram will be comes like this. This is the bending moment BMD. This is the SFD. Total positive. So this shear force and bending moment diagrams represent the variation of shear force and bending moment. Based upon these values, we are calculate or design the beam reinforcement, concrete, aggregate. These will all comes under design section. So here not important. So based upon these values, we are design any beam. So this is the importance of shear force and bending moment diagram. Next section we will consider another problem on simply supported beam. So thank you.